You didn't know we had a YouTube channel?
I never watch it.
Wow, that's sad.
I don't want to hear your voice when I'm at home.
Now, for the record, we're actually taping in B1 today instead of normal A3 because of mechanical difficulties yesterday. Excuse me. But what we're doing, I'm actually going to let you guys get started today. I'll let you work with your group. What we need to do, we've got a situation where an Italian villa has square tables that the servers can push together to accommodate the customers. Only one chair fits along the side of the square table. They gave you a model for the first 5. So, utilizing your group, figure out how many chairs you can put given the number of tables that we have in our chart. I will give you guys one hint. If you start to struggle, start working through all of the questions down at the bottom. They will actually walk you through step by step how to figure out what the other numbers are. Okay? We'll give you guys about 7 minutes. That's why we're going to walk through it. Okay, back on this one. Now, for me personally, when I started this one, it was easiest to use the model to help me understand what was happening. So all I did is I went through and I said, okay, I can put one chair on each side. So how many chairs do I have if it's one table? 4. Then I said, okay, now they pushed them together. I can still get one chair at each side. 6. They gave me the model for the next one, so I can do that one easy. That gives me 8. At this point, I should be able to start picking up a pattern.
+2.
I'm doing something +2, right? I'm just changing it by 2 every time.
4 at the left side.
So 4, now I would +2 gives me 10. 5, I do +2, that gets me to 12. But now I really have to think about what's happening. So now if I look at this, if I have 50 tables that are all lined up, how many chairs can I put on the sides? On the sides? 100. Because I can do 50 on the top side, 50 on the bottom side, right? But then I have 2 at the end.
So that'd be 102.
So it'd be 102. Then if I get to 200 tables, now I have 200 all lined up. How many can I put on the sides? 400. And how many on the ends? 2. So I get a total of, okay? So what was I doing each time? I took the number of tables and I said, how many sides do they have? Because every table has, Helen?
So every table has 4 sides, but you could say like t times 2 plus t.
Okay. I could say t times 2 plus 2, but that would be incorrect.
2 plus 2.
Okay? So let's talk about this really quickly. Why can't I say t times 2?
Because you can't do t groups of 2.
Because I can't do t groups of 2, can I? I can't do groups of 2. I don't know what t is. But can I do this? 2t?
Yes.
Yes. That's 2 groups of t. At some point, if I understand what t is, I can substitute it in and I'll know what that equals. But I can at least model 2t. I cannot model t2. That's why we don't write it like this, guys. That's actually the only reason we don't. Because commutative property of multiplication, multiplying each of those, I'd get the same answer, correct?
Yeah.
If I know what t is. But because of the modeling aspect, understanding what's happening, I have to write this as 2t plus 2. Now, quick trivia question, math vocabulary question. If I have a multiplicative algebraic expression where I'm multiplying a number times a variable, this number now has a special name. It has a math vocabulary term that is associated with it. Madison?
I know it. No. Can I please say it, please?
Gus? Coefficient. You were right there, but it's coefficient, not coefficiency. So that term is called a coefficient. It's the same reason that t is called a variable. That's just what someone in the past decided to call it. Not me. Not that old. Okay? So that number has a special term called a coefficient. That just means I'm multiplying it by a variable, and it will always come before the variable in that multiplicative expression. Math. I just spoke math.
You spoke all languages. Hebrew.
I didn't say I was Jesus.
I said, what language did Jesus
He spoke all
Oh, did
Hebrew.
Jesus speak? He spoke, yeah, Hebrew. He was Jewish. Okay, are there any other ways to think about solutions to this problem? What ways did you guys go through as you were trying to talk in your groups? Christian? Jaren?
I was doing adding two. So then I looked at how much more from the 5 to the 50. I saw how many more tables they added, which they added 45, and then I doubled that to 90, and then I added the 12, which is 102.
Good. Okay. So he was actually just using the chart as it filled in. Was there anyone else that did I did and used the model? Hopefully several of us, that's where models can actually be really helpful. How many of you went, like Helen came right up with the expression. So you could also use that expression to do it, correct? Make sense? Okay, so the rest of this is just talking through what we just did. It's impractical to make a model of putting 50 tables together to make a long rectangle. If we did have a rectangle that long, how many chairs would fit on the long sides of the table? 100 chairs. Okay? How many chairs would fit on the ends of the long table? 2 chairs. So how many chairs fit in all? 102 chairs. And then that's where I said you could use that to help you out if you were struggling. Work with your group. How many would fit a very long rectangular table if 200 square tables were pushed together? 402. Okay. 402 chairs. 400 on the sides. And 2 on the ends. To help you understand where those numbers are coming from, so you can put those together. So if we let T represent the number of square tables that make one long rectangular table, what is the expression? I'm doing 2 times the number of tables, because I have 2 sides for every table, plus I have the 2 chairs at the end that I'll add on at once I get everything else done. Questions on that entire process?
No.
Does it make sense?
Yes.
Okay. Good. So now we've got a couple more examples. So I'm going to give you guys another 6 minutes. Yep. You're going to finish up the rest of this on page 97 and 98. No, 99 is homework. It is. She just yelled at you guys yesterday. Guys, let's listen. Unfortunately, we have an activity I want to get done, so we need to get through this. Okay, Pizza Queen has a special offer on pizzas, $4 each. They charge $2 to deliver regardless. That's actually a really important key, because how many times am I going to be charged that? Once. Does it matter how many pizzas I order? No. Okay. Of how many pizzas ordered. Determine the cost. So there's a task for various numbers of pizzas. Also determine the expression that describes the cost of having pizzas delivered. So if I order 1 pizza, how much does that pizza cost me? No. How much does the pizza cost me? $4. How much does it cost to get delivered? So how much total? $6. If I order 2 pizzas, how much does that cost me? If I order 2 pizzas that are $4 each, how much does that cost me? $8. How much is the delivery charge? So what's my total? $10. If I order 3 pizzas, how much does that cost me? Plus a delivery cost of $2 means it's a total of 14. Are you seeing the pattern? So for 4, it would now be what? 18. If I had 10 pizzas would cost me $40 plus the delivery, 42. If I had 50 pizzas, how much would that cost me? $200 plus my $2 delivery cost. I don't know how you added 2 to 40 and got 44.
Oh, so you spending $200 on a pizza.
I've done that before when I was hosting dances. Okay, so what did we do to the number of pizzas? Multiplied it by 4, and then so what mathematical operations did you need, guys, please, to find the total cost? What operations did I do?
You did a multiplication and addition.
Good. So we had multiplication and addition. Okay, our next part. Suppose our principal wanted to buy pizza for everyone in our class. Determine how much this would cost. So we had, yes? Okay, okay, so you did C. Why 6C? Why 6? How much does each pizza cost? $4. Plus 2. And in this case, you should add that C equals the number of people in class. So basically all we did was change our variable from a single person to the number in our class specifically. Okay? If you actually counted, saw that there are 16 students, you could have multiplied that out. 16 times 4 would get me 16 times 4, 84, plus 2, 16 times 4. Oh, times 4, I had the 6 on the bottom. Yes. 64 plus 2 would be 66. So if the Booster Club had $400 to spend on pizza, what is the greatest number of pizzas they could order?
They could order 90 pizzas.
That's the most they could order?
98.
Why 98?
Because 98 divided by 2 would be, hold on.
Why are you dividing it by 2?
Wait, what was
I don't know. You said you were. That's what I was asking.
Oh, because 98. So if they have $400,
Uh-huh.
each pizza,
$4.
$4. So, wait, what am I saying? I was thinking, okay, wait, no, because, wait, yeah.
Karen?
99.
Why 99?
Because if you times 99 times 4, you get 396, then you add 2, then you get 398.
So I don't have enough money left to get another one. So you are correct. 99 pizzas could be ordered. Couldn't do 100 because then I wouldn't be able to pay the delivery charge. Although having done this before, if you actually talk to them and you're ordering 100 pizzas, they'll normally waive the delivery charge at that point. Okay, pizza price was raised to 5. Delivery price was raised to 3. Create a table. So there's a task that shows the total cost, pizza plus delivery, of 1 through 5. Include the expression that describes the new cost of ordering P pizzas. So now one pizza costs me how much? 5. Delivery card, now that makes it $8. Then it goes 13, 18, 23, 28, my new expression. Now it's $5 times P plus the $3. Does this make sense?
Yes, sir.
Any questions on anything we've covered? Because this is very similar to what you're going to be doing for your homework. So let's turn the page. Couple of things on the homework that I want to point out. When you see this word regardless, that means I'm only doing it one time. If I have something I'm only doing once, what operation is that? Addition. If I'm doing it repeatedly, what operation is that, Harold? Harold? What operation is that? Exactly. Please pay attention. I'm helping you on your homework. I'm helping you on your homework here. Recommend you listen. Guys, realize you have a part B and C here. Don't forget to answer those. As you go down, you'll notice number 2 has that same setup. I've got something happening repeatedly. I have something happening once. That tells you I'm going to have 2 operations. Again, part B and C. Number 3, they mixed it up even more. Now I have 2 before I start the table. So don't forget those 2, and you have 1 afterwards. Make sure you answer all of the questions. Number 4, this one you're just filling in the missing from here down. You're going to use this to figure out where 165 is finally reached, and then do your expression. Then on your last page, they give you an expression, and they tell you what to put in. So you have to substitute that number into your expression and solve for it. Number 6 is one of the more interesting ones. Hopefully we have no mass murderers, but we will find out on Wednesday if you guys understand math or if we kill people. Don't worry, when you do the math, you'll see. Okay, right now I need everybody to get out a blank piece of paper.
I knew it, Mr. Moore. What are we doing?
Get out a blank piece of paper. On the top, guys, listen up. On the top of your paper, you need to put your name, and then you need to title it, Writing Expressions. You can go ahead and number it from 1 to 25. We're going to have 25 problems that we are going to do.
What am I
Writing expressions, just like it says on the board. No, it says title it, Writing Expressions. Okay? We have 25 problems. They are on both sides of the room. Don't disturb Miss McShann. She's working. But you may use both sides as long as you're quiet. You may work with one partner. You guys are going to have 9 minutes. I'll give you 9. 9 minutes. All you're doing is writing the answer. You don't have to copy the question down. Just write down the answer. Make sure you put the correct answer with the number. You don't have to do them in order, but you do have to have the number, the problem in the right spot. Go. You have 9 minutes. Okay, first one, product of 3 and A. 3A. If you did a dot, that's okay. If you did an X, it's wrong. If you did A3, that's minus 1/2. 3, more than. More than is a flipping phrase. A plus 3. If you did 3 plus 8, minus 1/2. Number 3, A split into 3 equal groups. That's a division. You could either write it as a fraction or with the division symbol. Either one is fine.
Wait, if it's
5 less than G. That has to be G minus 5.
Wait, hold on.
No, number 4 is G minus 5. Okay, number 5. 5 more than G. More than is another flipping phrase. So G plus 5. If you did 5 plus G, minus 1/2. 5 minus G, that's just straight up. 5 minus G. 7, 6 subtracted from H. We haven't really talked about that, but subtracted from is another one of those flipping phrases. So I have to have H and subtract 6 from it. H minus 6. There's only one option on that. The quotient of 6 and H, quotient is a division. So either as a fraction or with the division symbol. 6 comes first. Number 9, 6 times H, straight up, 6H. No X's. Other than that, you should be good. X greater, dots are okay. X greater than I. Greater than is a 1. So that's another flipping phrase. 1 plus X. X plus 1 gets you a minus 1/2. That's minus 1/2. Okay, double X. 2X. Half of X. Now it's being divided by 2. And again, either fraction bar or division symbol. Either is acceptable. 13. 8 equal groups of M. 8 M's. The sum of M and 8. No flipping phrases, so we just write it as it's written. M plus 8. We did 8 plus M. That's a minus 1/2. M less than 8. That means a flipping phrase. M is less than 8. N split into M groups. N split into M groups. That's a division. 17. 4 more than. That's a flipping phrase. Twice R. Twice R plus 4. 3 less than the product of 4 and R. So my product needs to come first. 3 less than that. 4R minus 3. Again, you may use a dot. You cannot use an X in that one. H divided by 6. Very straightforward. 2 subtracted from F. That means I'm taking 2 away from it. 21. 2 minus F, straight up. Double X less than 5 means that's a flipping phrase. 5 minus 2X. N times N, just straight up. You can put a dot, not an X. T more than N. N plus T. If you did T plus N minus 1/2. Last one, the product of 3 and Y, 3Y. Total number wrong on top. Make sure your name is on it. Turn it into the box. This is for a grade.